In this problem, they're asking us to integrate a rational function, which is a ratio of two polynomials. We usually get to skip the first step. First step is make sure it's proper. Make sure the degree of the top is strictly less than the degree of the bottom. If the top has the same power as the bottom or a higher power, then unfortunately you have to do long division first. And this is one of those rare cases where we have to do that. So write down the long division. Now, one thing that you may or may not want to do, that leading part there, the x squared minus 1 is missing a term. There's no x term there. That's okay, but that can cause some formatting issues as you go through the division process. So sometimes to make things cleaner and nicer, if there are any missing terms, you may want to fill them in. So I could write that as x squared plus 0x minus 1. Now the drawback is I'll be wasting time. I don't really need to do that. I'll be writing down terms I don't really need. But the advantage is things will format really nice. Things will fall into nice clean columns. So it's your choice whether you do it or not. I normally don't. But when you first learn long division, putting in the missing terms could be a good idea. First step is to ask how many times does the x squared go into 3x cubed? Or another way to say that, what do you have to multiply x squared by to get 3x cubed? And the answer is 3x. Write that above somewhere. The exact position doesn't matter, but the most natural place to put it is above the x. Then take that and multiply by all the terms in front. 3x times x squared is 3x cubed. 3x times minus 1 is minus 3x. See, here's where you notice the formatting issue. I'd kind of leave a space to put the x under the x. If I'd put in the missing term, I wouldn't have had to do that. It automatically would have lined up. But it wasn't a big deal, so I don't mind. Then we subtract. Now, subtracting can be a little tricky, and so when you first learn this, they often teach you to change from subtraction to addition. Adding is safer, but you can't just do that because it's supposed to be subtract. So to fix the damage, you flip the bottom signs. Subtracting polynomials and adding an opposite are the same thing, but adding an opposite is a little safer. When you add the cubes, they cancel. We have 4x squared plus nothing, which is 4x squared. 2x plus 3x is 5x. And bring down the minus 7. Repeat the process. Ask how many times does x squared go into 4x squared? The answer is 4. Write that above. Multiply by the stuff in front. You get 4x squared. And you get minus 4. Again, I'm going to leave a little space. Subtract, or better yet, add if the bottom sign's reversed. Squares are gone. A total of 5x minus 3. And notice I can't do it again. X squared doesn't go into 5x. Once your degree drops below the degree of the divisor, right now I've got degree 1, 5x minus 3 is degree 1, you know to stop the process. You have a remainder. Just tack this remainder over the divisor onto your answer. So we've shown that the original thing can be written as 3x plus 4 plus this remainder, 5x minus 3, over the divisor, x squared minus 1. And now we can already answer two of their questions. They wanted to know the coefficient of the x, so we now see that's 3. They wanted to know the constant, which now we know is 4. To get the c and the d, we have to do some more work. So let me erase this division. So I'm focusing on this now. If you're proper to start with, you'd be starting here. But if you're not, you first do the long division, you get the remainder part, and now you focus on that. We need to take this and factor the bottom completely. Fortunately, that's easy. It's a difference of squares. Factors is x minus 1 times x plus 1. Then you have to remember how the decomposition works. For each linear factor, like x minus 1, you get a fraction with that on the bottom and a constant on top. And just looking at what they're using c, so I'll use c. And this other linear factor has its own fraction. Constant on top. Looks like they're going to use d, so I'll do that. And then usually this next step's the hard step. We need to solve this for these constants. It's a bit messy because you have these fractions, so let's clean it up by multiplying by the least common denominator, which is this denominator over here. If you multiply the left side by that denominator, you just get the top. On the right, you have the c over x minus 1 times this LCD plus the d over the x plus 1 times the LCD. And you can cancel the x minus 1s there. You can cancel the x plus 1s there. So we're left to 5x minus 3 is c times quantity x plus 1 plus d times quantity x minus 1. Now, to figure out the c and d, there are potentially 3 methods. But the best one, when it works, is method 1. It doesn't always work, so sometimes I have to use method 2 or 3. But when method 1 does work, it's the way to go. And it works here. Method 1 is to plug in strategically for x. There are 2 real nice values at x you can plug in. One of those nice values is 1. And the reason that's nice is because when we stick 1 in, it's going to knock out that d term, leaving just the c term, which then will be easy to solve for. Plug in 1 on the left, you get 5 minus 3, which is 2. On the right, you get c times 1 plus 1, which is c times 2, plus nothing. Divide by 2, you get your c. c is 1. Which means I got that answer there. And the other nice value to stick in is minus 1. Because that's going to knock out the c term, leaving just d, which then we can solve for. If you replace x by minus 1 on the left, you get negative 5 minus 3, which is minus 8. On the right, the c is gone, c times 0, and it's going to be d times minus 2. Divide by minus 2, d is 4. Then goes there. And then the last step is to do this integral. And what we're going to do is replace the original integral, which we didn't know how to do, with this new integral after the division and this decomposition. So I'll start down here on the bottom, but I'll probably have to go to the top. So the original integral can now be written as an integral of 3x plus 4. We got that from the long division. Plus that remainder, which now we know is c of 1 over x minus 1, plus d, which we found out was 4 over x plus 1 dx. Let me now erase all this other junk. First 2 terms are going to be easy because it's just a polynomial. So just do the normal raise the power by 1, divide by the new power thing. Last 2 terms will just be a simple substitution. And then we'll finally have our answer. First term, when you integrate, is 3 halves x squared. Second term, when you integrate, is 4x. Temporarily, I'll just write these integrals out, but you could do these in your head. So we have integral of the 1 over x minus 1. I'm going to pull the 4 out of the other one. 4 times integral 1 over x plus 1 dx. And then for this first integral, we're just going to let u be the bottom. du is dx. The second, similar, let u be the bottom. d is dx. So the answer is 3 halves x squared plus 4x plus, we're integrating 1 over u du, which is ln absolute u, which in this case is ln absolute x minus 1, plus 4 times, same deal, we're integrating 1 over u du, which is ln absolute u. And then a c, though they put the c in for you. So this is what goes right there.